First, introduction. Variables revisited. Throughout our course, we've used variables like integer age equals 30, without really thinking about what happens under the hood. We know that age holds the value 30. But where does this value actually live? The answer is, in your computer's random access memory, RAM. To fully understand pointers, we must first understand how this memory is organized. Second, memory. Think of your computer's memory, RAM, as a vast one-dimensional array of storage cells. Every single box, storage cell, has two fundamental properties: address and content. Address, a unique number that tells the computer exactly where the cell is located. This is usually represented as a large hexadecimal number, e.g., 0x7ff7, etc. Content. For the int data type, this memory box is one of the 4 parts of the data content of the variable. And for char data type, just need one memory box contains the complete variable value. Because int is 4 bytes, then we need 3 more boxes, and char is 1 byte. When you declare a variable in C, the compiler reserves a certain number of adjacent boxes, e.g., 4 bytes for an integer. For example, the memory addresses will be 0x00, 0x01, 0x02, 0x03. It places the content 30 inside those cells. It assigns the address of the first box to the variable name age. Third, the printf function and memory. When we use the variable name age in our code like this, about the age variable, the operating system knows at least 2 things: its first address and its data type. I am speaking about the first address, and the OS knows the data type of the age variable to be integer, for bytes equals 4 addresses. When it knows what the first address is, it also knows the 3 next addresses from the first address. Because these 4 addresses are located next to each other, like 0x00, 0x01, 0x02, 0x03. If you know the first address is 0x00, so you can know the 3 next ones, 0x01, 0x02, and 0x03. You can get the value of 30 from these 4 boxes. Just only know the first address. The variable name, age, is just a human-readable label for a specific first memory address. When people say a variable has an address, they are referring to the first address. Fourth, memory terminology for pointers. Variable name, age. The label assigned by the programmer. Content, 30. The data stored at the addresses. Address, 0x7ffeef, etc. The unique location number in memory. The crucial point for the next lesson. Every single variable has an address, and that address is just another piece of data, a large number. Fifth, conclusion and next steps. We have established the foundational concept. Every variable is stored at a unique, numbered location, an address, in RAM, and it contains some content, the value. In the next lesson, we will introduce a new type of variable that exists solely to store those first addresses. Our next lesson is 6.02. Pointers. Pointers as variables that store the memory address of another variable.